Alright, for our quiz 6 review here, first problem here is that given a data set that has a mean of 40 and standard deviation of 5.2 and a sample size of 25, solve for the following information. So the first part is just to write out what the point estimate is for this information. So depending on what you're trying to estimate depends on what your point estimate is. So in this case, we're going through and estimating in terms of the mean here. So that means that this sample mean here of 40 is our point estimate, because that's what we're going to add and subtract the margin of error to. That's what's called the point estimate. So here we'd have our sample mean, which remember the symbol for sample mean is x bar, is equal to 40 would be our point estimate. So that's what we're using to estimate the population mean here. And then for the margin of error, in this case, our sample size is 25, and we're dealing with our data set, which means that it is from a sample. If it's from a sample, it means we have S instead of sigma. We have the sample standard deviation instead of the population standard deviation. So that means in this case, we're going to need to use a t-distribution. You'll want to check out that flowchart in the book if you're still not quite sure how to decide between a t-distribution and a normal distribution. The main difference is in terms of the sample size. If the sample size is 30 or more, then you're definitely using the normal distribution. If it's less than 30 and you're dealing with values from the sample, then it would be a t-distribution. So make sure that you're reading through these carefully to decide which one to use. And the formula that we're using here is one of them that's actually going to be given at the bottom of the quiz on the second page, which we'll be getting to here in just a little bit. I'll write it down. We have T sub C, and then it's times S over the square root of N. S, remember, is your sample standard deviation, so that would be the 5.2 here. And then your N is your sample size, the 25. And then the T sub C, remember, is your critical value from your t-distribution chart. So whenever you're using your t-distribution chart, we need to know the percentage of our level of confidence. So in this case, it was 95. So you go to the level of confidence of 0.95 in the table. So write that down. Level of confidence, your C here, is 0.95. And then we have to go down to our degrees of freedom. Remember to find your degrees of freedom. It's always your sample size minus 1. So in this case, your degrees of freedom would be 24. 25 minus 1 gives you 24. So you go to 0.95 and then go all the way down to 24 and then see where those values intersect. So here for your T sub C here, for that critical value from the t-distribution chart, looks like we have 2.064. And then once again we had S, our sample standard deviation of 5.2, and our N was the 25. And then it's a matter of plugging in those values to get your margin of error, which remember is what that capital E represents. So here we have the 2.064, and then remember it's multiplied by your standard deviation of 5.2 divided by the square root of 25 there. And then if you go through and enter that into your calculator, if you enter that correctly here, it looks like you should get about 2.15 here. And then remember, once you have what that point estimate is and your margin of error, we can write out our confidence interval. And you can either write it in terms of an interval with the parentheses, or you can write it on the number line like they do in the book, or you can go through and write it with the inequalities like they also do in the book. I prefer to do it with the parentheses, so that's what I'm going to write out here. But there are definitely multiple ways of writing these out. And remember, you always put the smaller number on the left side. So you're going to do the 40 minus the 2.15 first, comma, and then 40 plus 2.5. So remember, this really means that you're talking about the values in between these two numbers. Maybe you write it this way, between the smaller number and the bigger number there. So here, if you calculate that out, looks like we get 37.85 for the first value, and then the comma, and then the second one is 42.15. And then you have to interpret your results here. So to interpret your results, that's where you're writing out what exactly that confidence interval means here whenever we're going through this. So I'm going to go ahead and type this out here. So we'd have that we can say with 95% confidence the population mean, so make sure you specify what population value you're talking about here. We're talking about the population mean here is between, and then you write out your two values, the 37.85 and the 42.15, or something close to that wording there. That has to do with the confidence level there of the population mean. You need to specify what you're talking about in terms of your confidence level, and then what your two values are between there. So that would be in terms of the interpretation. So make sure you're writing all of that out, because once we get to the test over chapters 6 and 7, you'll also need to go through and write all of that out, but I won't have it separated into the 4 different parts there, but all of that will still be expected. So make sure that you are getting in the habit of doing all of those steps, as I've been telling you guys in the homework as I'm looking through your work. And then number 2 is doing a similar thing. So remember, number 1, you do have to decide if it's a t-distribution or a normal distribution. For number 2, this one will definitely be a normal distribution one, because we're dealing with a proportion here. Because here we have in a survey of 1,800 U.S. adults, 800 favor increasing funding on research on wind, solar, and hydrogen technology. And we have to use that to go through and write out this other information here. So here, first of all, for the point estimate for our population proportion P, those in favor of increasing the funding for research, remember that sample value for the sample proportion is your P hat. P with the little triangle looking thing over top. That's called your P hat. That's your point estimate there. And to find that here, you do the number that we're in favor, so in this case the 800, divided by your total, which was 1,800, which is also your sample size. And remember, whenever you're dealing with probabilities or proportions, those should always be between 0 and 1. So if you accidentally divide it backwards and get a number more than 1, you're going to want to make sure that you correct that, because those values should always be between 0 and 1 if you're doing it correctly. So here, if we divide that out, we get approximately 0.44 there. And then remember, anytime you have your P hat, you also want to write out your Q hat. So we'll need that for the second part, so we might as well go ahead and write that down here. Remember, you always do 1 minus whatever you had for your P value there. So then whenever you're going through and writing that out here, we get approximately 1 minus 0.44, which is about 0.56. I'm putting in the approximation since we rounded that first value there for our P. We rounded that to about 0.44. normally want to go at least 2 decimal places. You can always go at more. The more decimal places you go at, the more accurate your information is. Alright, so then for the margin of error here, have yet another formula here. Keep in mind here our level of confidence that we want here is 90%, so we'd be looking for C, or confidence level of 0.90. And remember our N here is the 1800, the total of how many they surveyed. So not how many that answered the way they wanted, but how many were surveyed total. And then for our margin of error formula, the one that we're using out of these ones that are listed at the bottom of what you'll have for the quiz. So it'll just be these ones that'll be listed on quiz 6. And you will not need all of them. You'll just need some of those. So make sure to keep that in mind. You don't have to use all of them. If you're using all of them, then you're doing something wrong. So make sure that you know how to pick which ones to use and what the symbols mean. Dealing with the one with proportions this time. There's only one of them dealing with proportions that has to do with the margin of error. So we're not solving for the sample size here, we're solving for the margin of error, so we need that one. So then for our Z sub C, if we look that up in our normal distribution, that's one of those that's in that little box in the corner of our normal distribution. For our critical values there, we get 1.645. So that way you don't have to go through and calculate that each time. You go through and use the value from the table there, from the little box at the bottom of your normal distribution table. And then it's a matter of plugging in your values here. So here we'd have the 1.645. And then remember it's being multiplied by that square root, and make sure everything there has to go underneath that square root. Otherwise you are going to get a different answer there. So make sure you're careful how you're entering this stuff into your calculator. Depending on what type of calculator you have, it's going to depend on how you're going to need to enter that in. So it's the 0.44 times 0.56 divided by 1800. So depending on your calculator, you may need to put parentheses around everything that is inside of that square root if your calculator doesn't do that automatically. And for your margin of error here, it looks like you should get approximately 0.02 here. And then once again for your confidence interval, it's a matter of going through and adding and subtracting your margin of error to that point estimate. So you're adding and subtracting it to the p-hat value, since we are estimating the population proportion of p here. So you do the 0.44 that we had for our p-hat in part A minus the 0.02, and then comma, and then the 0.44 plus the 0.02. So if you do that here, we get 0.42, comma, 0.46. Then we'll go ahead and write out our interpretation again. One way of writing that out here. So here, for instance, we can say with 90% confidence that the population, make sure to state which population value you're working with here. It's the population proportion of those in favor of this research is between 42% and 46%. Since remember, proportions are dealing with decimal values, which can also be converted to percentages here, because your proportions are really another way of saying a probability that you think that is going to happen. So make sure, like normal, if you do have more questions on this stuff, make sure to ask before the quiz.